This is Andrew Wicklund with Project Risk Consultants. We're to the 7th step of our risk analysis. So the final step is really generating the reports and scenario modeling. So I'm going to mention this in every module that we do from here on out. But risk analyses usually fail in terms of reporting and generating steam because we give only bad results. The whole purpose of doing this is to not only give the bad news, but tell people how to fix it. So if you build a good statistical model and it gives someone bad news, they'll throw it away. If you build someone a good model, give them bad news, and then tell them how to fix it, you're a hero. So that's what we're going to aim for now is turning you into a hero. So the first chart that we're going to look at is the confidence level histogram. The confidence level histogram and the tornado chart you will see in every risk analysis you ever do. If you can explain those two charts, then you're in good shape. Now what we're going to do is generate a curve directly to our reporting milestone. So what I'm going to use for our reporting milestone is project completion. So I'm going to right click project completion. This is generally the easiest way to generate these reports. There is a reports menu. You can get to these same items. Also shortcuts. It really is easier, especially if you create some filters. I can say, I can bookmark this activity, show only my bookmark task. So that way, if I had two reporting milestones that I had filtered for, now it's real quick and easy. Right click, show the distribution. So that was the last option. Right click to the bottom, distribution, and then your tornado chart is below that. So we're going to look at the histogram chart now. Now it's laid out, and we'll kind of take this once again from top to bottom, left to right. So first you have your menu bars. So all your options, your copy and paste, your formatting, the graph. Some of this that you can look and navigate, look through the help menu and find some of this. But we'll slowly go through a lot of this that you can actually get to instead of through the menu bar by clicking on the graph. So if you look on the left hand side, this is your entire plan. So I just clicked off the activity I was on, it's changed, and I'm getting a histogram for any activity I want. So we were on project completion, so that's what we're going to look at. So there's two parts to this. One is explaining this. The second part will be not just explaining it, but navigating it and using this data to move forward. So first of all, when you look at this chart, what does it mean? This is where people struggle. If you struggle with what it means, especially in an interactive session or in front of management or the owner company, you lose all credibility as a risk analyst. What does this chart mean? It confuses people because there's two y-axes. You've got one for your hits, and you've got one for the cumulative frequency. So I ran this simulation 1,000 times. Now I'm going to jump down to the bottom left hand corner, and you can see the histogram, the bar width is set to a month. I can change this. I'll change it to week. Notice there's smaller bars. Each bar represents 1 week. So I'm going to change this to 4 weeks. So each one of these bars is 4 weeks. So I ran this 1,000 times. If I look at this tallest bar and trace it to the left, 130 times out of 1,000 times it landed in this 4-week bucket. So by doing this, I can look at and I'm seeing where every simulation landed. So I could do it by quarter, and I could say 200 times it landed in this quarter, 350 times it landed in this quarter, 250 times it landed in this quarter. So the bars are based on you're setting up a bucket, and it's saying how many times did that simulation end up in that zone. You read this the same way. Under the graph you'll see there's a chart for finish date, start date, duration, float, cost. Cost and schedule you're going to read the same way, except instead of a time period for the bar width, you're going to end up with a cost amount. So instead of it's a quarter, you're going to say it's $250,000. So you read it the exact same way. You can run this for resources as well. So notice there's a tab for tasks and one for resources. So you can generate resource curves in this screen as well. So if I click on that, I can generate the resource curves, and I can see how many man hours, how many, we'll look at this for labor hours as soon as this finishes running through. You read it the same way. So I've got a labor curve now, and I can look at that, or a cost curve, expenses, material. So you read those the same way. So now I've got all, I can see what the simulations means. I'm gonna set this to month, so you can see where the buckets are, and each one corresponds to the number of hits. All these red bars now are going to add up to 1,000 iterations. Now, based on, say, we'll take an 80% confidence level. An 80% confidence level is the point at which 80% of my simulations finished on or before that point. So if I look at where this line connects to, and I'll set up a highlighter. You can do this by right-clicking on the graph and clicking Format Highlighters. Right-click on the graph. You've got all your options for setting up the different looks and everything else. I'm going to click Format Highlighters. And if you set up the type to shade between values, I can do shade between a percentile, such as 80%. So this is a drop-down box. So I'm going to do between a 80% and deterministic, because I want to see the delta between what I scheduled and what my 80% is telling me. So I can set up arrows. So I've got an arrow pointing to 50%. I've got one pointing to 80%. Clicking the Add button towards the bottom will let you add a new one. So if I want to add in an arrow for a P10, I could see what that is. So I'm going to go ahead and click OK. And this I'm going to show my P80 contingency. So the difference between what I scheduled and the 80% is 206 days. Obviously at that point you've got a lot of explaining to do. So this is why we're going to be proactive and tell people how to fix it with the tornado charts and the S-curves and what have you. But at this point, everything to the left of this where you see the end of this green bar, that's 80% of the iterations. So when you explain this chart, it's important to mention to people we have an 80% chance of finishing on or before that date, because all of these simulations add up to that. So the point, if I go to 70% confidence level, if I trace these red arrows back and count the tick marks, that's going to be 700 out of my 1,000 iterations. So you've got two y-axes and they intersect, and you've got one timeline at the bottom here. So the way you would explain this though, if I want to be 80% confident, and normally there's a metric within your organization. The metric is generally set. Most people want to know their 50% chance. The higher end, the 80%, the 70%, people want to know their chance of hitting a certain, to accept this project, I want to be 80% confident. If you give me 80% confidence and enough contingency to be 80% confident, I'll accept the project, or we'll pass this stage gate. The higher risk the project, normally the higher that metric is. Projects where they're simpler and we can do more things on the fly to correct, more routine type of projects, maybe we need a lower confidence level because we're good at sequencing on the fly. So I'm going to take an 80% confidence level and say, if you want to be 80% confident, our 80% confidence date is June 13th. Now originally we had scheduled that we would be finishing at the in November. We only have a 7% chance of hitting that November date. And it looks like we need an extra 206 days if you want to be 80% confident. Either that or we're going to have some mitigation strategies or remove scope. So if you want an 80% confidence level, we need 206 days, or we need to come up with some workarounds. So once again, this is bad news. A lot of times a contractor will say, well, we can't report this, throw this away, and make one that says I have a 50% chance or a 60% chance. And that's really, it's defeating the purpose of doing this, and it gives Monte Carlo analysis a terrible name. We're 206 days late. Let's look at the inputs. Are any of the inputs wrong at this point? If we can't point to the inputs being wrong, then really what we're looking at is something's wrong with the project and we need to take corrective actions. So let's look at the bad news and see why it happened. If the inputs are right, then the answer is right, then we need to take action. So if we sweep it under the rug, this is probably going to be what happens to us. So it's really a proactive measure. Now, when I right click on the graph, I had some options. When I right click on the statistics, I have options as well. So you can format the font, copy the statistics, do all of that. I'm gonna format the layout. Now you can show different items. I'm going to select them all. The key and the reason I want to bring all of these up, one thing we've stressed is convergence. We want to make sure that the plan converged. This converged in 200 iterations. So I ran it 1,000 times. It converged in 200. I know I ran it enough. So at least I have faith that the curve converged. So I'm good there. Now as I go down, I ran a Latin hypercube simulation. That could be Monte Carlo if we hadn't checked that. It shows the number of iterations, statistics for everything, standard deviation, kurtosis, all sorts of things. Now, the reason I show you all these statistics is sometimes people will put on a screen every statistic in the world. And a rule of thumb, and this sounds bad, but don't show anything that you don't want to explain. And it's not because you can't explain it or you don't understand it. It's because in a group setting, people will get so hung up on the in-the-weeds details that they don't understand, like a standard deviation, and start arguing about it, that people lose sight of what the data is telling them and what the data means. This data means we need 206 days. If you want to be 80% confident, we need 206 days. If you're looking at standard deviation, you need to stop right now. I need to let you know we need to bring the schedule back in line 206 days. That's what you need to be focusing on. So when you look at the rest of these, some of these metrics, they're good. You want to make this, base this to what your audience can understand and comprehend. But a simple is oftentimes better. People get very confused by these charts. I mean, you've got two y-axes, you've got bars, you've got a cumulative curve. You could put shaders on here. I could put a picture of a Christmas tree. I can do all sorts of stuff with this. But if I make it more complicated and I make it harder to understand, is that better? Sometimes if I just show the cumulative curve, people go, oh, I get that. That makes sense to me. So you read this the same way. Generally also in terms of when we go through and we pull the charts and we put them into Microsoft Word or Excel, if you right click and copy the graph and statistics, the format actually isn't as pretty. So I'll go ahead and pull these and show the difference between the two. If you right click, copy graph and statistics, and I'm going to hit Control V, it copies it to my clipboard. You can see it's very difficult. I can't read the statistics, hard to read what the chart says, hard to read much anything on that. And as most people know, how pretty the graph is often more important than what it says. I right click and I go to copy graph and I paste that graph. Now I can actually read that. Much easier to read. I can see the dates. I might want to highlight, remove some of these highlighters and simplify the graph even, and copy it now. Simplify it, make it look better for people, make it easier to explain. It's not for your benefit, it's for your audience. I can right click the statistics text now, and if there are things I want to show, I can paste this into Excel, and it pastes it in column view, so I can go through. I can set up my borders and my shading. I can take only the parts I want. I can adjust how it's justified and everything else. Maybe copy that below the graph. And now all of a sudden, this is much easier for people to view. So it's very important that you put this in a format where people don't go, oh, it's ugly, so it's wrong. It seems like a stupid thing to say in a training class, but if the data doesn't look good, the better it looks, the more people have faith in it. So it is important it's statistically correct. It's important that you can explain this properly, and it's also important that it looks good. So the last part that we haven't mentioned is in the bottom right hand corner, and also in the tools menu, you have show in distribution analyzer and add to the distribution analyzer. This is actually going to pull these curves out and put them in the S-curve analyzer. So if I want to pull a couple of these curves out, I'm going to add it to the distribution analyzer, and then I can show in the distribution analyzer. I can show these curves side by side. So this is what we're going to use this for. I just gave you some bad news potentially. Now, if I can show you some scenario curves side by side and say, here's the bad news, but look at this curve side by side. I gave you some good news next to it. I saved you 100 of those 206 days. People start looking and going, oh wow, it's a sales tool for mitigation steps that you should be doing. You know, you're asking for money for mitigation. Oftentimes people don't want to spend money without proof. These charts are the proof. So if you scenario model well, you can say, hey, I can save you 150 days, but we really need to put about $1.5 million towards A, B, and C. We can't bring things back in line unless we get a second crew here, we start working weekends, and then we use a different contractor for the flooring. You know, it's a scenario. Why am I going to give you the money? Why are we going to do these steps? Because I'm going to save you. So we'll do a scenario modeling exercise. So we'll look at those S-curves in depth. But you can go through and add these. You can show any curve side by side, whether it's a cost and a schedule curve, whether it's curves from different plans. All it does is put it in a box for you to put them side by side. So this is an overview of the histogram chart. Like I said, it's important it's pretty. It's important that you explain it correctly, and it's important that it makes statistical sense.